students. How are you? I hope you all are fine. Students, in my previous video, I have explained what is refraction of light. And today I'm going to explain the effects of refraction in our day-to-day life. Students, so welcome to our science channel Sandeep and E.learning. Let's start. Students, appearing of a pencil or a streak bent while it is immersed in water, or appearing of a coin a little raised if it is immersed in a glass of water, or appearing of a swimming pool shallower. These are the different effects of refraction of light that we have already discussed in my previous class. But today we are going to read about some more effects of refraction. Students, in a night sky, we have seen that the stars appear twinkling. And this twinkling of stars happen due to the refraction of light coming from them. Students, the stars are located very far, millions of light years away from us. And the few light rays that comes from the stars, that light rays have to pass through the different layers of atmosphere, and different layers of atmosphere have different density. So every time the ray of light changes the media or it enters into the other or different medium of the atmosphere, different layer of the atmosphere, every time it refracts, it deviates from its previous path. So this way, after several refraction, when this ray of light finally reaches in our eyes, we don't see the stars in their actual position because the final ray of light totally changed. The route of the final ray of light that reaches in our eyes, that is totally changed from the original route that came from the stars. That's why we cannot see the stars at their actual position. And while the rays refracts at different layers, for a fraction of second, the stars disappear, goes off from our sight, and again the very next moment it again appears. When the ray of light takes up a new route, then the stars again become visible. So these things happen, students. The stars appear twinkling. So this is the refraction of light in different layers of atmosphere causes the stars appear twinkling. Students, refraction also causes mirages in sandy desert. And also this due to this refraction of light, we experience advanced sunrise or delayed sunset. Students, at dawn, when the sun actually has not come in our horizon, but still we can see there before few minutes of the sunrise. Why? Because though the sun has not come in our horizon, but the light ray, the ray of light that comes from the sun, after several refraction, as their route changed, as their path deviated, when it reaches in our eyes, we can see the straight. We cannot follow the bent path of the light. We would see it straight. So just when that light from the sun comes in our eyes, finally, we can see the sun in our horizon, though actually the sun has not come that time. This is the reason. Actually, the sun rise after few minutes, 4 minutes. After 4 minutes, before 4 minutes of the sunrise, we can see the sun in our horizon. This is the reason of advanced sunrise. And same thing happens, students. Same thing happened at sunset. The sun, when actually goes off from our horizon, we can still see the sun in our horizon because the ray of light that comes from the sun, after several deviation, we can see following the straight path of that deviated sunlight, we can see the sun in our horizon. So this refraction of light causes delayed sunset. Students, there are mainly two laws of refraction, that two basic laws that govern the refraction of light. The first one is what? The incident ray, the normal, and the point of incident, and the refracted ray all lie on the same plane. Means the incident ray where it strikes at the point of incidence that lies on the surface of separation of the two media, and the refracted ray also comes out from that point, means from the point of incidence at the surface of separation. All these three, incident ray, normal, point of incidence, and refracted ray, all lie on the same plane. And second law, students, for a given pair of media of different densities, the ratio of the value of angle of incidence to the value of angle of refraction always gives us a constant value. Means the sine of angle of incidence to the sine of angle of refraction always gives us a constant value. Here it is given the sin I and sin r equals to a constant when the pair of media are fixed. Students, this law first represented by a Dutch astronomer, Wilbrod Snellius, and after his name, this law is named Snell's law. Students, Snell's law says us that the value of this constant is fixed for a set of two transparent media, and it depends upon their nature. And it is also called, students, a refractive index of the second medium with respect to the first medium. And students, as this refractive index is the ratio of two similar quantities, it gives us only a value. It doesn't have any unit. Students, refractive index is represented by the Greek letter mu, and it has no unit because of being similar, the ratio of two similar quantities. And this refractive index, students, not only gives us the ratio of the angle of sin I and sin r, but it also gives us the ratio of speed of light in vacuum to the speed of light in the given medium. Here you see, students, mu, it is the speed of light in vacuum, and upon speed of light in medium. Means the ratio of speed of light in vacuum to the speed of light in a given medium. Students, in this table, the different transparent media and the refractive index is given. So when ray of light from vacuum enters into air, its speed changes at this rate, 1.0003. Or when ray of light from vacuum enters into water, its refractive index is 1.33. It means its speed changes or decreased at this rate. Same you see, students, alcohol, diamond, and kerosene, all these transparent medium have different refractive index, which depends on the nature of the medium. So students, using this formula, we can get the refractive index of any given medium if the speed of light is given. And students, this refraction of light follows some rules. Students, it is the first rule that the incident ray must strike obliquely at the surface of separation. Means at the point of incidence, the incidence ray must strike obliquely or slanting. And when a ray of light from a rarer medium enters into denser medium, its speed decreased and it bends towards the normal. And for this reason, the value of R, the angle of refraction, is less than the angle of incidence. And students, the second rule is when the ray of light travels from a denser medium to a rarer medium. So when the ray of light changes its medium from a denser to rarer, so in rarer medium, its speed gets increased, and as the speed gets increased, the refracted ray moves away from the normal. Here you see, students, it is the original path from which the refracted ray deviated in the rare and medium, and the refracted ray bends away from the normal. And this time, the value of incidence is less than the value of refraction. And the third rule, students, if the ray of light strike at a right angle, strike at a right angle means strike straight at the point of incidence while it changes its mediums, then there will be no deviation, no bending of the refracted ray. In the second medium, also the ray of light follow the same path, following the same route, the ray of light travels into that. So when the incident ray is striking at the point of incidence at 90-degree angle, then there will be no refraction, no deviation from its original path, and it will follow the straight or same path. Refraction of light through a prism. Students, a prism is a glass block and it has a triangular cross section. And prism is formed by three rectangular faces, and its rectangular faces are refracting surfaces. Means if any ray of light falls on the prism, it won't reflect, but it would get inside the prism, it will travel inside the prism, and it will go out from the other side, other surface of the prism. First of all, students, I would like to explain the different rays that are drawn here. Students, this is XY is the incident ray. This is the first ray, incident ray. And it strikes or enters into the prism at point Y. So point Y is the point of incidence at the first phase. And this is the normal in N1. And along with this normal, this incident ray XY has made the angle I. This is what? Angle of incidence at the first phase. And after entering into the prism, as glass is what? More denser than air. So the ray of light or this refracted ray gets refracted or bends towards the normal. And it has made the angle of refraction R1. But this refracted ray again becomes incident on the second surface because it is going out from there. So this refracted ray is incident at point Z. And here the normal is N2, N3. At point Z, here you students, this refracted ray is incident. And when it is going out, this ray is called emergent ray. And the emergent ray has made an angle with the normal, that is E. This angle is called angle of emergence. But this angle R2, it is called the incident ray, the angle of incident at the second phase. So students, it is clearly visible that the incident ray, which should have been passed into the prism and followed this path is extended. It was the original path of the ray of light that get inside the prism. So this was the original path. But after being refracted two times, once inside the prism into the denser medium, again from the denser medium, when it is coming out and coming in the rarer medium air again, then again it got refracted. So what was the total deviation of the original ray of light? This angle. Student, this is the angle of the prism, and this angle is the total deviation. The ray of light which should have been followed this path, but after being deviated this much, it is totally changed its direction. So students, this is the angle of deviation. And if we just add up the value of this angle of incidence and this final angle of emergence, then we'll get the value of these two angles will equalize the angle of deviation will equalize with the value of the angle of deviation and the angle of the prism. So students, I hope you understand. Students, in my next video, I'm going to explain the dispersion of white light. So keep watching. Thank you.